Let me discuss number 5 on test number 2 first. This is a question. The region is enclosed by the curve y equals 1 minus x squared. Okay, and x equals 0, y equals 0. So that is the region, right? You're going to rotate it about the x as the y-axis. Okay, so this rotation is about y-axis. So this is a picture you're going to see. Set up an integral for the volume. Okay. Now, to solve the problem, so it depends on which method you're going to use, right? If you want to use disks, when you draw the disks is a family disks. So the family depends on y variable. So the volume, I want to see, you will get, I want to see something like that. At the moment when you write down this, you probably will not make a mistake. I did not see you write down that one. Okay? So this is the area of the cross section. Then you will see that it depends on y variable, depends on x. It's clearly depends on y variable. AY is the cross section, the area of the cross section, and the dy is just a thickness. So you get the 1 slice of that, and that's the volume. So, okay, then you know you're going to use the y variable, you're not use x variable, and you can solve the problem. So the radius is going to be, yeah, this is the point of x and y. So AY is just equal to pi r squared. Okay, and you have to express r in terms of y variable, But look at this point here, r is going to be just x. Right, r is going to be x, but the x should be expressed in terms of y. So this is going to be square 1 minus 1. Right, square 1 minus 1. Okay, you solve for y or for x in terms of 1. Then it's integral from 0 to pi, and the 1 minus 1 is squared. Okay. Right. So do not write down the integral directly. Okay, you have to write down the original version first. Then you're trying to figure out how to compute it, because that will tell you immediately the variable should be y. Right. Yeah, the meaning of a of y times dy is that slice, the thickness. Yeah, that's a slice. That's a dy. So that's the meaning here. Ay and dy. That's the area volume of this ay times dy. So that is a volume of that slice. Okay. And then you get them together, you get total volume. All right. Okay, so now we are going to talk about the limit first. The limit. The first problem is to find the limit as, yeah, that's going to be like a 5x squared minus 1 and 3x squared minus x plus 3. So this is a limit as x approaches positive infinity. And to solve the problem, you just need to modify the expression, right? 5x squared minus 1 over 3x squared minus x plus 3. It's just divided by x squared. The numerator divided by x squared, the denominator divided by x squared. and you get, then you will see that, this is going to be easy. You can see there's a limit. Right. So this clearly approaches 5 minus 0, 3 minus 0, plus 0. So it's going to be 5 of 0. So to solve the problem, you can just put the answer here and show the details. That's what we do. Okay. Now the next problem is about the side limit. Okay. The side limit here would be x squared minus, x squared minus 1, and then here x minus 2. So how to analyze the data? Okay. You look at whether you can simplify that. If you cannot simplify it, then, and clearly, x squared minus x minus 2, you should express like x squared minus 1 times x minus 2, divided by x minus. So when x approaches 2, from the right-hand side, from left-hand side, will be 2 squared minus 1, it's positive. But this one, when x approaches 2 from negative side, this is going to be negative infinity, okay? Because when x approaches 2 from negative side, x is less than 2, and x getting close to 2, okay? So that's the reason you get a negative. Then the answer will be negative infinity, so you can put a negative infinity. I think this will be a complete argument. You can see how do you figure it out. You cannot just put a 1 over the infinity minus 2. That does not tell you the sign. 1 over 2, minus 2, then you get 1 over 0, right? So this will be, x approaches negative 2 means two things. X approaches 2 and x less than 2. So that implies x minus 2 less than 0, equivalent. And then this implies x minus 2 approaches 0, okay? So that means x minus 2 approaches 0 from negative side. Okay. So this is sometimes we put 2 to the positive side or 2 to the negative side. Okay, so let's look at this. When you plug 2 for x, you will see the numerator is going to be 0. The denominator, I'm not sure. Let's look at it. 2 is a 4 plus 10. It's also 0. So it's 0 over 0 type. So that means the numerator and denominator both contain the factor of x minus 2. So you have to, the limit probably is not going to be infinity. Even the denominator approaches 0, but the numerator also approaches 0. So you should simplify. You should simplify the first x minus 2, x plus 2, x minus x plus 7, and x minus 2. Okay. Then x minus 2, because anyway, for a polynomial, if you plug 2, the polynomial becomes 0. You must have a factor of x minus 2. Then you say, how do you know x plus 7, x minus 2 so quickly, right? If you don't know, but at least you should know x minus 2 is a factor. Otherwise, this is not going to be 0. So the idea is just do the division. Okay? I know it should be divisible by x minus 2. So I can get it as a fact. So x squared minus 2x, and do the subtraction, 7x minus 14, then the plus 7. And I get 0. So that's why this is where how do I get it as a fact. If you already know one of the factors, you can use the long division to get it as a fact. Okay? I knew that there'll be x minus 2 there, because when I plug 2 for x, the denominator becomes 0. Right? So the answer will be this. This is a simplifying term. Then then x approaches 2 from the positive side. It'll be 2 plus 7, 2 plus 2. So it's 4/9. So you can put 4/9 here, and here's this is the argument. So very clear. Okay. For the final exam, if you really have a limited time, what you should do, go over the problems we discussed in the class. Okay, 5 hours later, you cover the solution I gave here, and can you recover it? Can you do it? Okay, if you know how to do it, then you should get an A on the final exam. No problem, I guarantee it. Okay, yeah, guarantee it. If you know, it's similar problem, like a cone, right? We did it in the class, and you knew that, right? And you cannot remember how to do it. Then you cannot guarantee it. I did not modify anything. The problem if you look at my lecture notes, I discussed in the class, I did not even specify the value for the height of the cone, for the radius of the cone, just I and H. Then I determine the dimension of the cylinder inside the cone, which has a maximum volume. Or what I did is just let H to be 6, R to be 3, and put it on the test. Okay? Yes. Okay. All right, so the next problem is f of x equals square root of x plus 1. Okay, find the limit, or use the definition of the limit. I use the definition of the derivative to find the derivative. Okay, so it's the same, x plus h minus f. Okay. Sometimes we will ask, say, use the definition to find the derivative. Okay, it's the same, right? So you have to find this limit. You cannot just give me the formula. Okay. All right, so now let's find the limit, right? So f, the typical technique we're going to use here is going to be, if it's a square A minus square B, this is going to be square A minus square B, and multiply by square A plus square B, divided by square A plus square B. That's the technique. And then you can remove the radicals in the numerator. This is a typical technique. Okay. So let's take a look at and that would be, you have to understand the functions, the notation for the function. F of x plus h. There are still about 5 students don't know how to figure out how to express it. Honestly, I see that on the test. So if f of x is going to be x plus 1, f of x plus h will be x plus h plus 1. Okay? Just replace x by x plus h. Okay. Then use the above idea. Now, since if you already know the formula, then it's very simple. It's just x plus h plus 1 minus x plus 1 and divided by h. And I put a positive here. Positive sign, right? I already get that, so I know I don't need to with something. Okay. So now x plus 1 is gone. X plus 1 is gone, and only h is gone. Then only h is left. Then h canceled out. So you get this. Then you take a limit. Okay, you will get x plus h and x plus h, and that is going to be twice of that. So this is the limit. Okay, this is going to be the limit. Okay. Find the derivatives for the following problems. We have a bunch of problems here. And fx is going to be square root of x squared minus 1. Well, we use a chain rule to find it because this is, it's composite of two functions, right? Now, if you do it directly, this can be written as x squared minus 1 to the 1/2, right? So when you differentiate, that's more direct way to do. You view it as like a power function, right? So I remember this power function derivative with respect to u is 1/2 u to the negative 1/2, right? I'm going to use that. So here's 1/2 x squared minus 1 to the negative 1/2. But I have to differentiate inside. That would be x squared minus 1 prime. Right. So that will be 2x. Then 2x, 2 cancel out, just get an x. Okay. That is part. Yeah. Remember, if we have a f of x equals g over h of x, okay? The way we do is, and h prime x is going to be g prime hx and h prime x. That's a chain rule. Another version of the chain rule. Right, so the next one. All right, so this is a product of two functions. I can change it 2 to 12 to 2000, okay? But right now, I just like this. If I put a 2 there, then it's easy to square it. So some students prefer to do the problem, find the, then you have two possible ways to do it. Here's 2x and x, and double of that's minus 2 plus 1 of x squared. Then you multiply this out with 2x to the 4th power, and minus 4x squared and plus 2. Okay? Then you find the derivative very much easier. So before you do that, you should look at whether you can simplify the functions or not. Okay? So it's going to be 8x cubed minus 8x. That's it. But if you want to apply the product rule and the quotient rule, yes, it's very complicated. It works. But in some cases, you have to do that. If I give you the function 2x squared here is x minus 1x, 2018, find the derivative, then you cannot. Yeah, you cannot write down all the terms. Yeah, it's hard time. It's right 2018 years. You can never get it. Anyway, 2018 is still a small number, right? In the human, compared to compared to Earth's life, right? It's only 2018 years, right? But we change a lot quickly.
When you changed it from
-2, where's -2?
when you changed it from the parentheses from x minus 1
Yeah.
over x to x squared minus 2 plus 1 over x.
Yeah, this is a -2, yeah. Yeah, -2, 2x squared times 2. All right. All right, so let's look at it. No, you cannot do it, right? So you have to use the product rule quotient, right? And then the derivative is going to be, first of all, product, okay? And the plus 2x squared. And then the derivative of this, you have to apply the chain rule. It's 2018 and the 2017. Then you differentiate the last term. And you don't simplify too much, it doesn't matter, right? But at least you have to finish the derivative complete. So it's going to be 4x right? Then how about this? X minus 1 of x. The derivative, I think, is 1 plus x. I think I'm going to put x to -2. Yeah, write it this way. So I'm going to multiply this out. 2 times 2018. It's a bigger number than x squared times this. Multiply this out. X squared times x times 1 plus x to -1 will be just x squared plus 1. Okay, so that's it. We probably don't ask you to simplify the answer. If you really have to simplify, you may able to take the common factor out, this fact. Okay, if you take this out, and you take a 2 out, take 4, right? Then you can, yeah, you can, let's say, take 2x minus 1 of x to the 2017 out. So you will have a 2x left, this left, right? Plus 2018 and the x squared plus 1. Okay. All right, let's multiply this out. 2x squared minus 2. Yeah, 2x squared minus 2. So then I simplified 2x squared plus 2018 squares is 2020 x squared. And the 2018 minus 2 is 2016. Okay, so this is a big answer. Okay. Sine 2 theta. Now, if you don't remember the derivative cotangent theta, or you think it's too complicated, you can convert everything to sine theta, cosine theta. Okay, you shouldn't know the derivative sine theta, derivative cosine theta. So let's simplify this first. So there'll be 2 sine theta, cosine theta, and here cotangent theta will be cosine theta over sine theta. Okay. Then you will get sine theta plus cosine theta and multiply this out, 2 sine square theta, cosine theta. Right. So this is a quotient of 2 functions. and you cannot simplify it further, and you just differentiate by the quotient rule, and then you involve product rule also. It involves product rule. Yeah. Oh.
No. That was a few weeks ago.
Okay, so let's do it. Okay, sine theta plus cosine theta square, and the derivative sine square theta cosine theta. That's too bad. This is too complicated. Minus, and then derivative of sine theta plus cosine theta. Okay. All right. All right, so this is going to be, well, this is a product rule. We have to use a product rule and differentiate sine square theta, then you get 4 sine theta, and then get cosine theta, then cosine square theta, and minus 2 sine cubic theta. Now, this problem, maybe we will ask, don't simplify it. And if, yeah, this will be enough. As long as you show all the details there. Yeah, if you have to simplify, you have to take a sine square. Yeah, so don't have to simplify your answer. And you don't need to simplify. But you can, probably can still simplify a little bit. You have 3 terms in the numerator maybe. You get cosine sine square theta, cosine square theta, sine cubic theta, cosine theta. Yeah, that's 3 different type of functions. So we stop here. All right. The next one is about implicit differentiation. Implicit differentiation, that we are given y cubed minus sine 2 minus y, okay, and equals x. Okay. Find the dy over dx. And express it in terms of x and y. All right, so you just differentiate both sides with respect to x, but view y as a function of x. So what is the correct notation? That should be the notation. Don't put a dy over dx. Otherwise, this is wrong. Okay. So d over dx, it's kind of operating, acting on both sides, right? So the derivative of the y cubed will be 3y squared, and you have the dy dx, minus sine becomes cosine. Then the derivative of 2 minus negative y is negative dy over dx. Right. Then you simplify it, and you solve the problem. Okay. All right, so then dy over dx.
Let's find out from negative and positive.
Negative d by dx. You took
So I have a negative sign here. There's two negative signs. It becomes positive.
It's only negative if you took the derivative of 2 minus 1. It's 2
There's a two parts, yeah, two parts. It's not inside a differential y cubed, then a differential sign 2 minus y. It's two separate.
Right, but then why when
This is one term.
Takes the derivative of sign, so take the derivative of the inside function. Change it.
right, I get that, but in the next step, cosine positive.
Figured
Figured
out
out
negative from dy dx to the negative of the cosine.
Yeah, I have a two negative sign there. Two negative sign, negative becomes positive. Then I take the derivative out. Yeah. So we are given a function. Okay. So it's going to be 1 to 6. Find the absolute maximum value and minimum values. All right, so first of all, this is a continuous function. Okay. Right? It's a continuous function. Then the maximum value of the function, right, could be the value at the critical numbers, could be value at the endpoints. So what they have to do is they have to find the critical number. Okay. So in order to find the critical number, I differentiate, right? So the function here is x is negative 2 and minus 3x negative. It's 2, yeah. So this is or in other words, it's just negative 1 over x. Oh, sorry. It's the opposite. I have to include the critical numbers. Okay, so that is going to be minus here. So then I have a positive. Okay, all right. So it's going to be like, yeah, find the derivative. The question is how do you find the critical number? The critical number is going to be, this is 0, right? You solve that. So you can multiply both sides by x cubed. So again, negative x plus 2 equals 0. That implies x equals 2. So 2 is a critical number in the interval. Okay. The next step is we have to find the value of f of 1. At the end point, it's going to be 1. Okay. 1 minus 1 plus 1 or 1 minus, so it's just 1. Then I get f of 2, 1 plus 1 over 2 minus 1 over 4. and that is going to be 1 plus 104. It's 1 quarter. Okay, so it's slightly larger than the 1. Then also should look at 6. It's 1 plus 1 over 6 minus 1 over 6 squared. Right? Yeah, 1 over 6 squared is a much smaller number. So it's 1 minus plus, I think, square 5 over 36. Okay? So is this number is larger than a quarter or not? I think it's less than a quarter. Okay? So this number is less than 1 and a quarter. Okay? So now it's clear that, but still larger than 1. So F2, this is the absolute maximum value. Okay? F1 is absolute minimum value. So all you have to do is just find the critical numbers and evaluate the function at the end. You don't need to know where the graph is increasing, where the graph is decreasing. Okay? It's not necessary. You can just be blind, just need to find the critical numbers. Then you check the value of the function at the critical numbers at the end of the point. Because the picture says that if the function is continuous, right? It could be like that, right? So this is A and this is B. You just needed to look at this special numbers. Right? At the end of the point, like this picture is a function I should draw the graph for the function. If I draw the graph for the function, it looks like here's a 1, here's 6, this is 2. Okay? It goes a little bit like that, and it goes a little bit below that. Yeah, still higher than the 1, so yeah, something like that. Right. Maybe somewhere it's up or down, we don't care. We just need to look at the 3 values, find the largest one. All right. So next one is a maximum minimum value problem. This is a very tricky problem. I'm going to make the problem. So suppose you have a little in the backyard, right? There may be like a storage room, right? 10 feet. So you're going to use a portion of that, and they're going to, so you have no fence on this side, and you're going to make a rectangle fence, right? So you're going to buy this. Okay. So total length you have is, so what you want to do is it's a rectangle, okay? Yeah, it is a rectangle. Okay, and the length is going to be 100 feet. Okay, but you can use 10 feet on the one side. Okay, that's your design, right? Sometimes you make a fence. There's already a little house over there, right? You use that. Right. Let me make 200, yeah, because I'm worried about the solution later. Yeah, 200 feet. Okay. So this is a house. So my question is, find the dimension, right? Find the dimension that such that the region has the largest possible area. Could be a square or not. We don't know yet. My opinion is that if it's just a rectangle, then clearly it's a fixed parameter, right? Square should have the largest possible area, right? But right now it's not clear. But you have a huge backyard. You bought a 200 feet long fence, right? And you have to decide which shape of gives the largest possible area. Okay, but it should be look like a rectangle, and including one side of the storage room, for example, 10 feet long. Right, it's a very practical problem. Right, so this can be solved by calculus, I guess. Okay. So this side, let's call I'm going to use the x, okay, then use the y. Okay, the total length, if you look at this picture, so total length will be, I think, 2y plus 2x but minus 10. That should be 2,000. Now 200, right? That's the parameter will be 2y plus 2x minus 10. So the area is going to be, right, is going to be x times y. That's it. So from the first equation, x plus y is going to be, 2x plus y is going to be 210. So x plus y equals 105. Right? Then you can write down the area function in terms of x. So that's it. So we want to find the maximum possible area. But is there any restriction on x? I think the x must be greater than or equal to 10. Okay? Because otherwise, this will not look like the one we like. Yeah, the length should be longer than 10 feet. Okay, otherwise you're not going to cover the whole storage. Right, but that's good enough. When you look at this function, you will see this is a parabola. And here's a 105. Its parabola opens downward. Right? And here's a 10. And x never be less than 10. Okay, that's fine. So what x is the area has the largest possible value, right? I think when x equals a equals maximum, when x equals half of that, right? So it's going to be 52.5. So that is x, right? Then you can determine the y value. Then you solve the problem. So y is going to be, it's also 52.5. Right, so that is the dimension. You can decide. So this is a half of the point. It's done. Okay, sometimes you're given the area, you have to find the dimension so that you use another problem is the areas are fixed. Okay. And you want to find the dimensions of the rectangle so that you have used the shortest length of fence. That's another problem. It's a similar style, right? It's a similar style. Then you go to store to buy them because you really want to show my dog needs so much area, at this age. I walking around, it's recommended 100 square feet for the dog to play around. Okay, then you do the calculation and how long the fence you have to buy. Okay, you can get a little bit more longer, but this is a mathematics you can use. Okay. Yeah, so another problem is another question is still the same problem. Here's a x, that's a y. Okay. So the area, I know it's not a 100. I need I have 400. How about that? 400 square feet. Okay. Find the dimension such that the length has the shortest possible value. The length of the fence is minimum. Okay. So first of all, you are given a equals x times y equals 400. The length is going to be what? It's going to be 2x plus 2y, right? But you have to minus 10. So it's 2x plus y minus 10. Okay. And then you will, there's two variables, but the x and y related. So you can say 2x and plus 400 divided by x minus 10. Okay. So that will be 2x plus 800 x to negative 1 minus 10. So this area could be, I don't know how small it is, but the x must be greater than 10. Otherwise, this does not look like the correct picture, right? So you have to have, that's the restriction. Yeah, x must be greater than 10 to make the fence. The x can be longer, right? All right, so now you get a function like that. So you have to find the critical number, okay? I know when x goes to infinity, this is the length is getting infinity, right? When x, so this is a function defined on 10 to infinity, right? So this is x, that's L, okay? And I think eventually, yeah, we're going to find the minimum value, okay? So the value when x equals 10, so that would be 2 times 10 plus 800 divided by 10 minus 10. I don't know what happens. Okay. So simplified, it'll be 10 and 80. So it's going to be 90 feet. Okay. But I'm not sure this is the smallest value. Okay. But the L and x goes to infinity as x goes to other infinity, clearly. Okay. So I have to find the derivative. Okay, so you will get 2 minus 800 x to the negative 2. And set this to be 0. right? So you will get x squared equals 400. So x equals 20. Great. X equals 20 is a pretty number, but I'm not sure it has a smaller value, right? So you look at the value at 20. So I'm going to get 2 times 20 plus 800 divided by 20 minus 10. Okay, let's see. 40 plus 40 minus 10. So 70. Okay, 70 is the smallest value. Okay, how does the graph look like? The graph looks like that. Here's a 10. So this is L, this is X. This will be 90. And the 20 here is 70. It goes like that, okay? So this will be the smallest value for the length. So what you have to do is, you have to make when X equals 20, the Y value will be what? Y equals 400 minus 20. That will be 20 again. So when X is 20, Y also should be 20. Okay. And then the total length is going to be, it's actually square, still the square. Right? Yeah, surprise, it's still the square, but the total length just need a 70. Okay. So X should be called 20, Y is going to be 400 divided by 20, which is 20. Okay. In this case, area is 400. Okay. And the length is the shortest. The length is going to be 20 plus 20 plus 20 plus 20 minus 10, so it's 70 feet. It's a square. We proved that it's a square. All right. Find the area of the region bounded by y equals sine x, and x is between 0 and the pi, and the x-axis. Okay. So that should be an easy problem. Say you draw the graph. Here's a pi, here's 0, and that's the area. That's the region. Okay, we know the formula, right? So the area is going to be integral from 0 to pi, just sine x dx. I think this is an easy problem. So that is going to be negative cosine x, evaluate at 300 points, negative cosine pi plus cosine 0, which is 2. There are some more complicated problems will be like you have to find the intersection points, okay, and you have to determine the another problem is similar to like that. Find the area of the region enclosed by y equals x and y equals 3 minus x squared. Hold on, wait a minute. 3 minus. I think I have to put a 2 here. Otherwise, it's not a good problem. Okay, so yeah. So step 1, you know that this is going to be like that, right? Or maybe more vertical because the slope is. And then this is a parabola, opens downward, right? Okay, so this is the region. Okay, this type, the most difficult problem will be something like that. So you have to find the intersection points. Oops. Those 2 intersection points. How do you find it? 3 minus x squared equals 2x. So x squared plus 2x minus 3 equals 0. And if you factor, so x will be plus 3 and x minus 1. So that's why I was trying to make a nice problem, you know, and the x equals 1, x equals -3. Okay, so you will get, yeah, -3 and some number and the 1, and then when x goes to -3 has -6. So you get a picture like that. Then the area of this region is going to be those vertical lines, right? The length of, so L and X, for any given point X, you have to find the length. The length of this cross section is going to be the curve on the top minus the curve at the bottom. So this will be the length, okay? So the area is going to be integral from -3 to 1, the length function, okay? Okay, that's it. So I'm not going to finish the computation for this, but at least you get an integral for the area. So this type of problem will be most complicated problem on the test if that it shows up. Okay. The next problem is about integral. So it's very similar to the one I put on the test, but I really want to, where's my test? I don't have it here. So integral of 1 plus square root x squared. This one, yeah, so many students make a computation mistakes. Okay. The best way to do, I really like the way they use substitution. But there were 3 students using substitution. Okay, honest, I can give you the number. The substitution is let u to be 1 plus square x. Right? Then du equals, okay, that's fine. So the integral becomes u squared but the dx over d squared u is 2 du. And see, if you use the substitution, that'll be very simple. N plus constant, and then 1 plus square u and the cube plus c. Okay. But the answer key I give to the grader, and he graded the first page, is not that one. So he even did not pay attention, so he graded, marked it wrong, so I make a correction. And look at it, okay? So this is a beautiful method, okay? Let's use substitution. Then if you don't want to use substitution, that's fine. Then there are several students made mistakes, okay? So if you don't want to use a substitution, just square. Okay, it is going to be 1 plus 2 square x plus x, yeah, right? Then you have 1 over square x, so let's get that. Then you have a 2, then you have x to the 1/2 dx. Now, many students just get rid of this 2, just drop it. Okay, 2 is there, all right? The integral of 2 is 2x. Okay, so you have to find the entire derivative of each term. This will be 2x. Okay. So you don't need to learn more to get high scores in some time. Just need to pay attention, don't make stupid mistakes. Okay, you already have this knowledge to solve the problem. So you don't drop the 2. 2 is there. Okay, then you simplify a little bit. It's going to be 2x to the 1/2 plus 2x and plus 2 over 3 x to 3 over 2 plus c. It looks like it's different from the problem, the answers, right? But they're similar. Okay, I won't tell you why this is similar to that. Okay, so you get 1 plus 3 square x plus 3 square x squared and plus square. That's good. Okay, plus no constant. So when you multiply this out, you will see that this is the same answer because 3 cancel out, and then this will be 2x. That would be 2 over 3 x to the 3 over 2. When you compare with those 2, it's the same. Okay, so it doesn't matter which method you use, you get the same function and plus a constant. Right. All right, so the next one is probably step substitution. You know, it's going to be the 2 type of problems. One is a more direct substitution. Okay, it'll be sine x, like, you know, here's 2 minus cosine x dx. Okay, something like that will be very direct. Another type will be cosine 2x sine x dx. That would be yeah. So let's change this. Sine 2x and then cosine x or sine x, doesn't matter, okay? You can have the cosine x. And this is requires more trigonometric geometry, okay? There are 2 types, okay? The first one is easier. What are you going to do? I think I just let u to be 2 minus cosine x. okay? Then du equals just sine x dx. It's simple, direct. Okay? Yes, the derivative of negative cosine x will be positive sine x. So the integral is just equal to du of u. Oops. This can be not done because it's not required yet, right? So let me put, come on, 2018. I like this. So 2018, you can do it. Okay, just one, yeah. Okay, so this is a power function, and you can say 2018 du, right? Then it's going to be okay. Yeah, the integral of 1x dx of x we don't know yet. Okay, so this is going to be negative 2017 u to the negative 2017 plus constant. And then you have to put back 2 minus cosine x negative 2017 plus constant. All right. Yeah, the last problem I want to discuss today is it's from 0 to 2. All right. So this is a function. Okay. So clearly you have to still use a substitution. You let u to be 4x plus 1, and the du equals 4 dx. Okay. Now, if you use a substitution for the definite integral, you probably have to change. Yeah, if you want to keep the new variable, then you have to change the interval for the new variable. So when x equals 0, u equals 1. When x equals 2, u is going to be 8. It's going to be 8 plus 1, so it's 9. Right, good. So the integral becomes, it's 1 to 9, and u to the 1/3, and the du equals, dx equals 1/4 of du. Okay. Then you have to find the antiderivative and evaluate that between the points. The only problem here, you get 3 here and 16 u to the 4/3 is to how to simplify it. Right? 9 to the 4/3 is going to be 81. How do you see that? No, no, I cannot simplify. Sorry, it's 80 is yes, the 9 is not. So we are not no, we're not able to simplify. That's it. That's what I say. Right. Yeah, 9 to the 4/3. You cannot simplify first. So we finished 9 problems here and plus additional problems. Okay. And the rest of the problems, I think we Yeah, I will try to cover next class.